Hey guys, welcome to Lecture 5, Equations of Motion. Here is your learning intention and success criteria. Please complete your KS table. Pause the video while you do this. Okay, so having a look through here, our first big bit of knowledge here is first understand how to use equations of motion. So that's going to clue us in our first bit to be what are these equations of motion here. And we're going to solve constant acceleration in 1D problems. So we're just dealing with one dimension. We've talked about this a bit earlier. So our skills here is we need to be able to, how do we use these things? And you're going to know if you can do this, if you can do two things. You should be able to interpret the questions to identify some physical properties, and then we need to apply the equations to solve for unknowns. And this step here, while it's technically harder and worth more, this bit is actually the easier part. It's this interpretation that people generally have a bit of issue with, so we'll go through a bit of that today. So, equations of motion. One of the big powers of physics is the ability to predict what will happen if we know some appropriate formula and enough information about the system to be accurate with our predictions. And with this we can do things like fly to the moon, build a nuclear power plant, or even develop drugs to help without randomly having to mix chemicals together. We sort of know what it should do, and so we can build it and design it. And this is going to be the main thing, because you can see this a lot throughout the next 2 years, where we'll have some physical concepts and then we'll have an equation that models it, and that's a big part of Western science. So there are three main equations mentioned in the formula booklet for the syllabus. Now you should make sure you have a copy of that formula booklet. It is on the eLearn website, so make sure you've downloaded it. And that booklet will be provided for you in its entirety for your Year 11 and Year 12 exams. So you need to be familiar with it. So that'll be on your data test exam. That will be coming up early on in term 1, and will be provided for you at your end of year final exam when you finish year 11, and same thing for year 12. But there are some other formulas that are very usable that don't appear in the booklet, and one of those will be on your textbook. So firstly, let's start off with the ones that will be in this booklet. So these equations use the following shorthand. We've got S for displacement, we've got U for initial velocity, we've got V for final velocity, we've got T for time, and finally we've got A for acceleration. Apart from displacement, and the text actually describes why we use S for it, all these things make reasonable sense. The way I remember that it's U for initials is because it comes before V. V is velocity. We need something to say final velocity, and U is the letter before V, so initial comes before final. So this little key here may help you a bit. And I note I've put down the units here: meters for displacement, meters per second, seconds, and meters per second squared for acceleration. Now there are two extra equations, and the way we get them is by doing some algebra with these three, and how we originate these is kind of tricky to do with anyway, but we're not going to cover that. And so again, we see the same symbols. Note that's a V times T minus half AT. It can look a little bit like a U if you're being a bit quick with your writing. Now, the thing that I want to heavily clarify here, and the chapter 10.6 covers this a little bit, unfortunately, is you don't need to know how these formulas are derived. I'm never going to ask you about it. It won't be on your exams. It's not part of the syllabus. Okay. What is important for you to recognize is that these three here will be on your booklet. It's weird, that's been plugged in for a while. They will be on your booklet. They will be given to you on your exam. These three won't. Oh, sorry, these two won't. Okay. Now, I've been told by QCAA, if you use those two at the bottom, there are no penalties, so you can use them. However, if you use them wrong, for example, maybe using equation 4 there, S equals U plus V over T, times T divided by 2. If you use it incorrectly, maybe you forget the divide by 2, okay? Or maybe for some reason you do U minus V, and then you divide it by 2. if you put it in wrong, you will lose marks, or you won't get the marks that you would normally have gotten. So you've got to be careful with that. Okay, make sure that you are, if you're going to use them, make sure that you remember them properly. However, you don't have to. Okay, you can get through any question just using those three. Sometimes you might have to use this one and then this one. However, it will still let you get, no matter what, with these three. I made it through these three through all of university. I didn't even know these two really existed until I was about 3 years out of university, just because it just wasn't relevant. Okay, so I will work today going through using these three only, and then we'll see how it goes from here. So this is the one big thing that scares students the most, rearranging equations, because if you look at these equations, maybe you've got v, u and t and you need to solve for a. Well, you're going to need to rearrange this equation. Or maybe you've got v, u and a and you need to solve for t. You're going to need to rearrange this equation. Maybe you've got s, u and t and you need to solve for a. You're going to have to rearrange this equation. Okay, and so this is more common than not that you will need to rearrange. And this is why you've been doing algebra and math for the last 4 years. Now if you're finding that difficult, you have to get the problem sorted early. Okay, Khan Academy, really great website to use. I heavily recommend you check it out, especially for your math, for your other subjects anyway. Make sure Math Help Room, if you're having a problem and you want to speak with someone face to face, go there. You've got other students, you've got other teachers. Finally, come see me at lunch. You might just have to bite the bullet, give up a couple of lunches now so you can hammer it out later. I had last year a young year 12 girl who had always had problems with algebra until she finally came and spoke to me, and we sorted out how to fix it in 20 minutes. And this had been a problem that she'd been putting up with for 6 years practically of high school. It is solvable. Okay, so this video is going to be reasonably short. Now we're going to get straight to some worked examples. The text does provide an example of this, however we're going to do it as well just so that you get kind of used to it. So let's have a read the question. A car starts from rest, reaches a velocity of 60 kilometers per hour. That power of -1 means per hour, which is 16.67 meters per second. Good, they've given us the SI unit there, in 8 seconds. Assuming the acceleration to be constant, calculate, and we'll get to what the calculations are asking for in a second. The first thing I'm going to do here is I'm going to work out what the question is actually telling me. And generally with this, the big thing in physics is look for the numbers. I have one number here, I have 8 seconds. And I have another number here, a 16.67 meters per second. There's a 60 kilometers per hour as well, but this is telling me that this is the same thing. They've just converted the units, and being as this is SI, this is what I want to use. Okay, they're my standard units. So how can we represent these as symbols? 8 seconds, that's a time, so we'll just go T equals 8. I've got a velocity here of 16.67, but is it my final velocity or is it my initial velocity? Since read the question, starts from rest and reaches a velocity. Well, that word reaches there would imply that's my final. So that's going to be V, because that was my symbol for final velocity. Now we don't have any other numbers, but we do have this word rest, and this is a word you're going to learn to pick up on. Starts from rest. What does it mean to rest? It means you're not moving. So our initial velocity, u, equals 0. Okay, there's nothing else here in this question we can read. Now let's see what does it actually want us to work out. Oh, what's the acceleration? So the first question here is asking us, oops, a equals, I don't know. Now have a flip back to your equations. I want you to look at those 3 equations at the top. Is there an equation there that uses T, V, U, and A? It won't have A as the subject necessarily. We're going to have to do some rearranging. But is there a formula that has these 4 things in it? I'll wait. Okay, now hopefully you've gone and had a look at it. If not, pause the video and go have a look at it. But you'll find the equation here is V equals U plus AT. We've got V, we've got U, we've got A is the thing we're trying to find, and we've got T. Now, there's two ways of working from here. Some people like to substitute the numbers in and then solve it. Some people like to rearrange it to get the thing they're trying to solve as the subject first and then put the numbers in afterwards. It doesn't really matter which you do, especially for these easier ones, but sometimes down the track rearranging and substituting equations means you cancel things out, which does mean it saves you a bit of time. So I'm going to substitute the numbers first because that's the way that most people like to start. So instead of V, I'm going to write the number 16.67 equals, instead of U, I'm going to write the number plus A, well A is the thing we don't know, and remember there is an implicit multiply between the A and the T here. Multiply that by 8. Okay, well anything plus 0 is itself, so that 0 can be ignored. And so we're going to have, if we simplify this, 16.67 equals 8A. How do we get rid of the multiply by 8? We're going to divide it. So we're going to have A equals 16.67 divided by 2, which is going to be, I'll grab my calculator, but it will be just a sliver over 2 meters per second squared. 16.67 divided by 2. Oops, sorry, not divided by 2. Divided by 8. 2.08 meters per second squared. Now it goes on for a couple of decimals after that. If we were going to 3 decimal places, we'd round off as 0.084, but normally 2 decimal places is pretty common with these sort of things. Also, we've been told here we've got 2 decimal precision here. While we've only got 1 digit precision here, we can just assume that they mean it's definitely 8 seconds, and so I'll let this be my guiding value here. Okay, so part B of this question is asking us the displacement, or the displacement is the symbol S. Now, it can be useful if you can use the 3 numbers we were given at the start, because there's no rounding error. This A value, while it's correct, is just a little bit off because we rounded it. We could certainly just use this number instead for A, 16.67 over 2 as our substitution, but that gets a little bit unwieldy. So have a look at the 3 equations at the top. Which ones can we use to work out S? Okay, now the first one can't because it's B equals U plus AT, but the other 2 equations I said that were in your text, that are in your formula booklet, are V squared equals U squared plus 2AS, and S equals UT plus a half AT squared. Now we can see here this one, we've got V, we've got U, we figured out A before and we can solve for S. Or this one here, we need S, we've got U, we've got T, we've figured out A and we've got T. So this one actually doesn't mean we have to do any rearranging at all, which some people like. This one here we'd have to rearrange. It's kind of a moot point really. So let's use the one at the bottom. Just because we don't have to rearrange it, may as well make it simple on ourselves. We're going to get S equals, well, U is equal to 0 times 8 plus a half. Well, A was equal to, well, let's put the whole thing in. 16.67 over 2 times T squared, 8 squared. Be careful with this, make sure you're only squaring the 8, not squaring the whole thing. 0 times 8 is 0, and then 0 plus that is just going to be that, so that bit here goes away. We're going to have S equals, let's work this through, 8 squared is 64. Half of 64 is equal to 32, and half of 32 is equal to 16. You could put all this thing in your calculator in one go. I kind of like to simplify some of it in my head a little bit before, so you do it your way and I will do it my way. So 8 squared, as I said, is 64, half of 64 is 32, half of 32 will be 16, so we'll have 16.67 times 16. And that's going to give us 266.7. Okay, so in each of these I did 2 things. One, I read through the question, I interpreted what information was given to me, and I listed that out. Second thing, I asked interpret the question, find out what it was asking me to do. I listed that out. And finally, I substitute and I solve. So these two steps here, this is the physics. These are the bits, working at the equation as well, sorry. That's the physics. This other bit here is just math. Okay, and math is a skill. We can practice math. This bit here, the reading and interpreting, that's the hard bit. And what a lot of people seem to have problems with is that if they can't figure out how this bit will look, they won't even start this. They won't even start the interpreting the question, and you can't do that. Okay. After a bit of practice, you will see that questions just generally look the same, and you go, oh yeah, I can that, and figure out the pieces. But to begin with, you can't. And you can't sit there and go, oh, I don't know how to solve this straight away, so I'm not going to even try in the first place. Okay? So focus on this first skill. Focus on the interpretation, because if you can do the interpretation, you're probably 3/4 of the way there. Okay? But you've got to do this step first. Okay, let's move on to the second worked example. So, again, we're going to do the same thing. First off, we're going to interpret the question. We've got a number here. We've got another number there. In this case, the question's barely given us any sort of context behind it. It's just hammered out the information straight away. So let's identify these. We've got 6 seconds. Well, that's a time. T = 6. We've got 30 meters. That's a displacement. And if we see here, starting from rest, there's that word rest, so initial velocity must be equal to 0. The first thing it wants, the acceleration after 6 seconds. So that's 6 seconds and that's 6 seconds means we're still dealing with the same time, so that's okay. And we just need to work out what is A equal to. So now if we have a look at this, we've got S, we've got U, we've got T, and we need to work out A. Have a look at the top 3 equations, see if there's a formula that we could use to work this out. Okay, so the formula we should use here is equals ut plus a half at squared. Let's make some substitutions. S is equal to 30. 0 times 6 plus a half a times 6 squared. Well, 0 times 6 is 0. 0 plus something is just going to be the something, so that will cancel away. 30 equals, let's see, 6 squared is 36, and half of 36 is 18. So A times 18 will give us 18A. And so A is going to equal 30 over 18. Let's see, 6 will divide into both, which means then that would be 5 over 3. Which is going to be equal to 1.67 meters per second squared. Okay, let's have a look at the second part. Second part here is what is the velocity after 6 seconds. So still 6 seconds, so we don't have to change the time. Note, if they change that 6 to an 8, that's a sneaky thing that to often do, then we wouldn't be able to use t equals 6, we'd have to use t equals 8. And we wouldn't be able to use the s equals 30 because we know that it goes 30 meters in that 6 seconds. So be careful with stuff like that, and I'll draw your attention to it when they come up down the track. And these worked examples, they're going to be pretty straightforward. So it's velocity after 6 seconds, so that means we're looking for a final velocity. Okay, having a look here. We've got a U, we've got an S, we've got a T, and we've got a V. We've worked out A, so we can still use that A. If we have a look here, none of the 3 basic equations or the 3 standard equations will let us solve it in one step, unless we use the A value. Obviously, we can use that. One of those optional ones we could have used S equals U plus V times T over 2, because we're trying to find V, we got given U, we got T, and we've got S. So we could certainly use something like this, but again, while I'm fine with you using that, and I do believe the textbook uses this, if you can get used to just using the top 3, it will save you a bit of hassle down the track, because you won't be necessarily be given this. So treat it like this. If you're really fine with remembering formulas, feel free to use this. This is probably going to be really the only area where you get given some extra formulas in the text that aren't in the syllabus. If, however, you find that memorizing formulas is a real tricky thing to do and you just want to focus off, well, here's my booklet in front of me, what are my equations that I'm allowed to use, that I am being given to use, go with that. That's perfectly fine. Okay, it's up to you to figure out the best way for you. So I'm going to use instead, since I'm after velocity, v squared equals u squared plus 2as. And the reason that the u is going to cancel off nice and quickly. So let's substitute that. V squared equals 0 squared plus 2 times a was 5 over 3 times 30. Let's see, 3 under 30 will go down to 10. 5 times 10 is 50, 2 times that is 100, so v squared will equal 100. And the square root of 100 is equal to plus or minus 10. You've got to be really careful with that. Square roots have both positive and negative answers. You've got to be careful with that. You have to choose what is the right answer. Being as we've said that s is positive, we've said that acceleration is positive, that it's travelling, maybe we're just saying that it's going forwards. I mean, that makes sense. It's a train, it's going forwards. If it was going backwards, we could say that backwards is positive. It doesn't really matter. So you have to choose the right value. And the reason for this is not so obvious when we're dealing with one-dimensional systems, but when we are looking at curved systems or systems that are moving up and then down, which we'll look at when we in the next chapter. There's a bit of that, we'll cover that in class. These numbers would make sense because this negative 10 means that it could be that maybe the train came from over here, came to this point 30, got to here to 0, and then went back the other way. And at this point it was plus 10 meters per second. At this point it was negative 10 meters per second. Okay, this is one way that this math would work. And so the question is, well, which one meets our story? This one is the only one that meets our story if it started at rest and went forward. 99 times out of 100, just choose the positive answer, and it'll be probably correct. Okay, so V equals 10 meters per second. Okay, have a look at how Walding does the two worked examples as well, just to see what differences there are. Now, underneath it, there is a challenge question, and this challenge question is not really about constant acceleration, but it is about constant motion. And I'll give you a hint for trying to solve this, because these sort of things are really good to try to cut your teeth on, and some of them are quite tricky. Often I will have to look these up and just try to figure out how to do it. So don't flog yourself if you can't do it, because it's not going to stop you from succeeding, but it will help you develop thinking and modelling skills. So what you're going to need is two pairs of equations. One will be for the officer and the army as the officer goes forward, and then one for the officer and the army as the officer goes backwards. And you're going to have to talk about displacements in terms of each other. For example, that the displacement of the officer equals the displacement of the army plus another number, or that the velocity of the officer is equal to the velocity of the army plus something else. Focus on displacements, and we'll cover it in class anyway, but have a shot at it, have a scratch at it. And quite often a lot of these things, you will be able to find them online as well if you do a bit of clever Googling. Okay, so in this video we've learnt the following. Our three core and our two optional equations of motion for accelerating systems. We've looked at how to interpret a question and identify physical properties, and then finally how to use those equations of motion to solve for an unknown. Now, for your entrance to class, please complete questions 1 to 9 in Chapter 10.6 Check Your Learning PDF. Copy your answers into the 1.5 space on eLearn, and you may like to pre-read Chapter 10.7 as we'll do that. That will be done in class in a coming lesson, and we'll expand on applying these equations to common 1D scenarios. So it's well worth having a look at. Thanks very much for your time. I'll see you in class, and I'll see you in the next video. Bye.